Fabio Pelligrini. We will speak about cogeneration in a domestic environment and why gasification, why biochar production can be a game changer in this application. I'm Fabio from Kira Technology, a SME from Italy, born in 2014. And we develop and produce a micro-CSP system for domestic and very low power application. In Europe, we have the 40% of electrical distribution network older than 40 years old. One house every 6, but in some countries, one house every 2 have an heating system working with oil or kerosene. 42 million people in Europe are not able to adequately meet their energy need. And in this scenario, we need a green transition. What is the need? Usually, when we think to renewable energy system, we think to PV panels, maybe to wind turbine. But this kind of energy doesn't produce power when we need. It produces power just when sun or weather allow it. Fossil fuel can do this job, of course. We can use a gasoline or diesel generator, but it's not renewable energy and is a very high cost. Biomass micro-CSP, biomass combined heat and power, is on-demand power production, but is absolutely not suitable for domestic application, for size, for operation, and so. A possible solution is to make a system with on-demand power production, but using a low-cost fuel, renewable fuel, with a home-sized power, home-sized operation, and with a very low environmental impact. So the possible technology to do it is a domestic micro-CSP with the same philosophy of big power plant, but with domestic operation and size. Using gasifier, this can match with a very low environmental impact because the burning of a gas is dramatically different than burning a solid fuel. And at the same time, he lets the system to be carbon negative because of biochar production. Biochar is the byproduct of gasification and contain part of the carbon content of the biomass that during the life of trees, of vegetable in general, has been grabbed from atmosphere. So syngas can be used to supply a burner and to heat up a Stirling engine, for example, very suitable for low power production and for domestic application because it is silent, it is free of maintenance, and it produces electrical current, of course, and hot water that can be used for heating rooms, for make sanitary hot water. In a domestic application, what we need is to produce daily all the energy that the house needs. There is a big difference between the philosophy to think the power that we need in house, because usually during the day we have a peak power production, a peak power need, but the mean value of this power is very low usually. So a domestic system should be run for a long time, store the energy surplus in battery, for example, and from batteries, house can keep the peak power needed in a certain moment of the day. So the micro CSP for domestic application should be sized on the energy need of the house and not on the power peak need. There is no modulation. This system should work always on the best efficiency point. Because of gasification, will make a better biochar quality. Stirling engine will have greatest efficiency, best electrical production, lowest thermal production, because it is very easy to make hot water from electrical power, and it is very hard to make electrical power from hot water. On the thermal side, we think about to use the typical puffer, hot water buffer, large tank with technical hot water, and we use it for produce heating, to produce hot sanitary water. It is possible to think to 3 generations. In some period of the year, if we have a large amount of hot water, we can also make a adsorption system producing cooling, air conditioning cooling, a chiller unit that absorb hot from the water, excess hot water production of this system. Biochar is a big added value of this kind of system, because there is not only electrical power, thermal power, but biochar contain a part of the energy of the input biomass, but at the same time contains a lot of carbon. All carbon contained in biochar is not transformed in carbon dioxide, is not put in the atmosphere, but can be stored permanently in the soil. It's a fantastic soil improver. There are many other applications possible for this material. And for example, a typical high temperature gasification system can make 100 grams of carbon sequestration every kilogram of biomass used. And this means 300 grams of dioxide carbon reduction from the atmosphere. The micro-CSP market globally, it's about $3.1 billion. In Europe now is about $1.44 billion, and the micro-CSP now is the market of unit below 50 electrical kilowatts. Obviously, domestic system is much smaller than this 50 kilowatt electrical, and so domestic cogeneration can expand this market, can be also larger than number you can see there. The market, the best customer for such a solution are countryside houses, not only off-grid, also on-grid are suitable for it. Houses, semi-detached houses, for example, or small apartment buildings, small farms, small greenhouses, and user, especially in the north of Europe, most interested users are those on high energy consumption or high cost of energy. We have to consider both heating cost or electrical cost. Competitor is mostly the combination of PV plants and heating system. Heating system can be also solar heating or traditional pellet or biomass boilers. Obviously, there are several advantages of micro-cogeneration domestic, because, for example, you can use low-cost biomass, typically residual biomass from forest, from agriculture, or from industry. There is a very high electrical to thermal production ratio. It means that you can use it in a larger period during the year, not only when you need so much heat and not much electricity. Biochar production, so the use of gasification is the only way to make the system carbon negative, and the low emission because of the burning of a gas, so no particular matter emission. Thank you so much. I give the floor to a use case